So I've had some questions about the psychrometric chart. So I want to kind of go over some of this stuff with you and see if I can help uh, clear up the confusion. All right, so to start with, down here at the bottom, these are our temperatures. All right, this is what we consider a dry bulb temperature, and they range from 35-ish, 30, 34, 33, 32. So we start at 32 degrees and it rolls all the way up to 120 degrees Fahrenheit. These curved lines are the humidity. And if you look very closely right here, here is those relative humidity. So this line right here is 30% relative humidity. So this line right here is going to be 100% relative humidity. We're either underwater, it's pouring the rain, middle of a hurricane, anything could be going on right there. This is also the line which condensation will adhere to surfaces. All right. So if you ever hear me say, you know, your tea glass starts collecting water, this is where that is. Now, let me give you a couple of what ifs. All right. So I've taken some of the questions off of the quizzes and I've changed them around a little bit. So we have a fall day that is 68 degrees. So let's start with 68 degrees. So 60. So if you see those lines there that fall into these lines here, that means that 60 degrees is this line right here. Let me make it a little bit wider so you can see it better. There we go. Okay, so let's go over here and find 68 degrees. So we have 65, let's see, 60, 1, 2, 3, 4, 5, 6, 7, 8. 68 degrees goes right up through there. And actually, let me use this. 68 degrees. Okay, so this whole line right here is 68 degrees. And we have a relative humidity of 40 degrees. And we have a relative humidity of 40% moisture. So I go in here and I find 40, which right there. So I'm going to, this line right here is 40% relative humidity. Now the question asks, how many degrees would it have to rapidly fall in order to reach dew point? So here is dew point. This curved line right here is dew point. All right, so we need to figure out if, okay, for one, cooler air is going to go this way. Warmer air is going to go this way. So we're going to go in this direction. Try to keep that as level as you can. How many degrees, I'll do this one more time. How many degrees would it have to rapidly fall in order to reach dew point? Well, it reaches dew point at this point right here. All right, so we know that over here, this is 68 degrees at that point right there. So we need to figure out what this is. So we've got 40, 41, 42. So this is 42 degrees. All right, so now what we need to do is we need to say 68 degrees less 42 degrees, and our answer would be 26 degrees. So it has to fall 26 degrees before we hit the dew point, or the saturation temperature, 100% relative humidity. Next question. A house is 50 degrees and the relative humidity is 45, is heated to 65, and what would be the relative humidity then? So we need to start at 50 degrees. So here is 50 degrees. There we go. All right, and we have a relative humidity of 45 rather. So we have 40 at this point. This is 40. This is 45, or 50 rather. So 40 to 50, and this right here in the middle is going to be 45. So at this point we have 45%, and we need to move to, okay, we're going to heat the house to 65 degrees. Remember that this way is heated. So we're going to go to 65 degrees. All right, and we're going to go from 45, keep this right on the level line there. I probably need to use a smaller line, and that one just completely disappears. I can't do that. All right, and you can enlarge this if you need to, so that you can see stuff. Whoops, wrong one. Didn't exactly keep that line straight. Let's try that again. So I'm going to make a level line from 45% relative humidity, and I'm going to keep it on the level. And use these lines, use these horizontal lines to kind of keep this straight here. So now we're looking at roughly, so right there would be, somewhere in this neighborhood would be 25%. So this is a little above it, so it could be about 26 to 27% relative humidity. Okay, remember that we go in this direction for hot, we go in this direction for cold. And in this particular case, we went warm, so we were going in that direction. We started off with 45% relative humidity, and we moved our way onto the heated side, so we're heating up. That means that our relative humidity is going to go down, and we're roughly 26 to 27% relative humidity. Next question. A room that is 65 degrees and 60% relative humidity is rapidly cooled to 50 degrees. What is the relative humidity? All right, so let me make sure that I said that right. 65 and 60. All right, so let's go up here and go 65 and 60 relative humidity. And then which way are we going? We are going to be cooled to 50 degrees. All right, remember, cold, hot. $50 degrees. Yes, 50 degrees. Okay, so I'm going to start here. I'm going to make this a little bigger. And I'm going to go along the level line. All right. So, look here what happens. Here's that saturation line. There's dew point. We crossed that line because we were going colder to 50 degrees, and we crossed it over. So, the answer to that question would be 100%. Next question. According to the psychrometric chart, if the temperature is 91 degrees and the relative humidity is 30, how many degrees can we cool a room and still remain in the summer comfort zone? So we have 91 degrees. And we have 30% relative humidity. So we got to follow this line right here. There's 30%. We're going to follow this line up to here. And can we cool a room? How many degrees can we cool a room and still remain in the summer comfort zone? All right, so we're trying to get as cool as we possibly can. Make sure you be real careful when you do these lines so that they're not funky, going crazy. All right. So the comfort zone is right here. Notice that these overlap. So this is this other dark spot here is where the crossover of winter and summer comfort zone. But this is the comfort zone, which is the blue one. And right here is the minimum that we can stay within the summer comfort zone. So it's asking how many degrees can we cool it. So we need to go down here and find out what this is here. And it is 73 degrees. All right, we started out at 91 and we're cooling to 73. And I'm going to cheat and use a calculator. I don't have enough toes to do this. All right, so the answer to our question here is 18 degrees. How many degrees can we cool a room and still remain in the summer comfort zone? All right, and the answer is 18 degrees. Last question. A spring day is 80 degrees. Here's 80. I didn't want to do that. Here's 80. And we are at 40% relative humidity. There's 40. Follow that line up. It's going to come to right there. How many degrees would it have to rapidly fall in order to reach the dew point? So, again, we're going perfectly horizontal here. And we are, I didn't want to move that. Stop it. Okay, so we are hitting it about right here. So we're talking 51, 2, 3 and a half. So, about 53 to 54 degrees. Okay, guys, I hope this helps. If it doesn't, please don't hesitate to ask me. I'm seeing that you guys are not trying the psychrometric chart off. You're not trying the quizzes very much, so it must be confusing to you. So if you don't understand it, give me a holler. All right, give me a text so that I can help you understand this better. Okay, see you guys.